real place cell, and this is sort of how this looks when scientists plot it in real data in their experiments. And when I post this PDF file, there'll be pictures of this that you can look at for yourself. But essentially, x-axis is position of the route on the track. The left y-axis is the firing rate of the place cell, which goes up here in the place field, the area where the cell likes to fire. The spikes of the place cell precess in phase against the theta oscillation, and the y-axis on the right side is showing us at what time, at what phase of the LFP does each spike occur. Each black dot is a spike of the place cell recorded across many, many repetitions of traveling through this place field. And you see that as the rat enters, you always have spikes occurring at this time, just prior to the valley. And as he travels through, the spikes precess, drop in phase to earlier and earlier times. And this could be, and this essentially is a graphic illustration from using real data of what is artistically demonstrated in this cartoon. Does that make sense? Yes?
How does this have anything to do, like the prediction that the synchrony between the grid cells and the surrounding cells would be together? How does that have anything to do with like our theory? Like what
Well, remember that what the theory states is that grid cells fire when they detect synchrony among their inputs. Grid cells and place cells both detect synchrony among their inputs, and that's what makes them fire. And the reason why their inputs aren't synchronized all the time is because they are rhythms of different frequency that are moving in and out of phase, that is, in and out of synchrony with one another all the time. Only at certain moments, and in this case it will be at certain locations, do they actually get synchronized with each other. And so the theory in a nutshell says rhythm generators of different frequencies become synchronized sometimes, and that's what makes a place or a grid cell fire. What do we see in this cartoon? Two rhythm generators of different frequencies getting synchronized with each other at a time when a place cell fires. So there is a clear sort of parallel. It's not proof that it's right, but it's clearly consistent with the concept. Does that make sense?
Yeah.
Yes.
That's what I'm confused about, because on the bottom axis is that the theta cell frequency, or is it the firing rate that we're comparing?
The bottom axis, the pink, and I'll label this better. That's one of the reasons why I haven't posted this yet. The pink is the spikes of the place cell as the rat runs through this place field. Okay, so we're hearing the place cell go pop, 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 as the rat runs through the spot that it likes to fire in, and that place cell is bursting at a specific carrier frequency, which turns out to be slightly higher than the frequency of the surrounding population activity recorded in EEG, which is why we see phase precession. But we also see synchrony in the middle of the place field, at the moment when the place cell fires the most. The biggest, most spikes per burst. Does that make sense?
Why is that?
Yes.
I'm so confused by phase precision in this like example. Like I understand when you talk about brushing your teeth,
Yeah.
they're like
Yeah.
in orbit, but I'm a little confused in this.
Well, it's the same thing. So the place cell is you brushing your teeth, and this is the Earth spinning on its axis. You're brushing your teeth at a higher frequency than the Earth spins on its axis. And so, since the place cell is bursting faster than the surrounding LFP, when we use the LFP as our clock for measuring at what time the place cell bursts, that time gets earlier and earlier. Just as when we use the rotation of the Earth on its axis as our clock for measuring what time we brush our teeth, the time we brush our teeth gets earlier and earlier. If we used, something that happens, if we used, I'm not an astronomer, so I don't know, but what planet rotates faster than the Earth? Anybody know one? Let's just say that Mercury, rotates faster than the Earth. I'm not sure that's actually true. I think maybe it doesn't even rotate. Anyway, but let's say that Venus rotates faster than the Earth. If we were using Venus time as our clock, then we wouldn't see phase precession for when we brush our teeth if we were doing it every 20 minutes. So it matters, everything is relative when you talk about phase and synchronization. You know, you say something is occurring at a higher frequency than something else. You're making a comparison between two oscillations. And here, all we're saying is that when you use this LFP as the clock for measuring at what time place cell bursts occur, you see phase precession because the clock is slower than the bursts. Does that make sense?
The burst of the
Place cell.
cells.
Yeah. Does that make sense, sort of? I mean, the time scale is way different. It's not a day, it's a fraction of a second, but it's the same principle. Yes.
What is LFP?
Oh, sorry. Local field potential, and I will put that on the slide when we put that. Local LFP is local field potential.
And what is that?
That is it's a synonym for EEG. It's the population activity of the neurons surrounding your electrode tip. It's the room noise that you pick up from neural populations near your electrode chip, as opposed to the individual place cell that's firing.
Okay, so if you have this electron right by cells, aren't this population neurons also by cells?
Yeah, and again, the analogy that's really helpful for understanding this, I think, is talking on your cell phone in a crowded party. You know, the person you're talking to will hear your voice, especially if you hold the phone right up to your mouth. But if you put it on speaker and move it away, or even if you just put it on speaker, you're going to be able to, the room noise is going to get through, and it's possible that you, depending on how you filter the signal, you could just maybe only hear the room noise and not the person you're trying to talk to. And that's essentially what the LFP signal is. It's letting in the chatter of the neurons surrounding your electrode, not just a single one that you're right next to. You're measuring that. Like, so in that sense, you're really measuring whether you could, by comparing the single unit signal of spikes to the EEG or LFP signal of the surrounding room, you're essentially asking the question, is the place cell in sync with the crowd or not? You can ask what the relationship is, right? Yes?
So do the place and grid cells only have this like regular firing pattern when they come into their specified location because the theta cells start firing at a regular rate, whereas when they're not in that place, they're firing randomly?
No, and so this is, I mean, I'm really glad you asked that question, because this is the thing that's, I think, that's most novel and also hard maybe for people to understand, even neuroscientists who aren't used to thinking this way. But the theta cells, if you listen to one of them, you would never detect any difference in what it does when the rat is in a location where a place cell fires or not. The theta cells just, it's not becoming more bursty or more regular at that location. The only thing it's doing is getting more lined up with other theta cells, which are also doing some stuff that you would never notice a difference in. It's only by looking at a group of theta cells and asking, are they doing what they're doing together, that you would ever be able to tell that this is happening.
We don't really know why they're lining up?
Well, that's the math that we're not getting into. The reason they're lining up is because their frequencies depend on velocity in the right way. But that's the whole idea here, is that, you know, that what a place cell knows is whether or not a certain group of theta cells are doing their thing together, whether they're dancing to the same music or not. And when they do, it fires, and when they're not, not. But if you just look at one theta cell, one dancer, you can't tell whether it's dancing with the rest of the chorus line. You know, you only know what it's doing. Does that make sense? Yes.
So is the way that we find that there's phase precession, it's by looking at where those like spikes are and seeing like 340 degrees. When you go to like 210 degrees, there isn't a full cycle. There isn't like a full phase. It's not at the same place in the.
So, sorry, let me, why don't you start that over again, and I'll try to.
So going from 340 to 210.
Yes.
There's less than a full
Cycle.
cycle.
Right.
Is that why is that like?
That's why you go.
That's the precession, right?
That's the precession, exactly.
So.
That's like 10 p.m., 6 p.m.
Right.
I'm brushing my teeth the next day at an earlier time.
But then where do the degrees like come into play? Like why aren't we looking at it from 0 degrees to 360 degrees?
Well, we are. So think about this is where the time of day analogy becomes helpful, right? Because the time of day
Or is it just it's just like a part of it, like you're just looking at a fraction of it?
Think of this as the time of day, and let's just call this midnight, noon, midnight, okay?
Right.
So every valley is midnight. So here, we're brushing our teeth just prior to midnight. Noon comes, and then because we're brushing our teeth only every 20 hours instead of every 24, on this day, so this is Monday, midnight, noon, midnight, Tuesday,
Right,
noon, okay?
Mhm.
So each cycle is a new day,
Mhm.
and but we use the same numbers to measure time, regardless of whether it's Tuesday or Wednesday or Thursday. So degrees here are time. So we brush our teeth just before midnight on Monday. Now on Tuesday we brush earlier than that because we're brushing less than 24 hours apart. So instead of 11:30 p.m., 6:30 p.m. you
Yeah,
have
I get
3:42:10, but it's the same thing. Does that make sense?
Yeah, that makes sense, but I guess I was just wondering why you would like measure it from these different points rather than looking at an entire
Passage through here.
right,
Well,
like 0 to
you
3%.
could. So, just like if we wanted to, instead of having a 24-hour clock, we could have a 1-week clock. We could have a clock that had 24 times 7 hours in it if we wanted. When you measure time, it's kind of up to you what reference frame you want to use. But anytime you have a periodic oscillation like this, it is extremely sensible to use as your unit of measure your position within a single oscillatory cycle. That's, in some sense, the most sensible clock to use. So these angles are simply times within each cycle of the LFP, just as the times we use to measure times of the day correspond to points of the, on the Earth's rotation around its axis. Because that's the thing that sort of regularly repeats itself, so it's just sort of the natural unit to use. I don't know if that makes sense. Yes.
So, on the bottom here, is this like measuring the bursting of the place cell or the rhythm generator?
The bursting of the place cell. These are the spikes of the place cell as it runs through the place field. Cha-cha-cha-cha-cha.
Okay.
Yeah.
So is the EEG like going back to like when we were talking about like how place cells you need like a whole bunch of rhythm generators to sync up? Is that representing all of those rhythm generators?
Possibly.
in one?
Possibly. But this is a good question. I mean, part of the reason why this finding is not conclusive proof for the theory is because nobody actually really knows what exactly this is measuring. It's the EEG signal. It's just like if you put your cell phone on speaker in a party and put it up. It's not like anybody can really listen to that and tell you who's at the party, right? You need more information than that to know.
Is that what we're assuming for this model though?
What's that?
Is that what we're
Well,
the assumption is?
I wouldn't say we're assuming that. I would say that we're just making an observation that is consistent with the theory but does not in any way prove or disprove it. Does that make sense? You certainly would expect, according to this idea, that oscillators should have different frequencies and that they should get synchronized when the rad is in specific locations. And lo and behold, that's what we're seeing here. But we are not seeing everything that the theory predicts, in full detail, right? So this is what we call evidence, not proof. Does that make sense? It's the difference between evidence and proof. An important distinction. And we are getting pretty late here. I have got a meeting at noon. I have to do an electronic meeting, so I'm going to have to run before very long. But we've covered pretty much everything here about. Are there any? So in the 3 minutes we have left, does anybody have something that they're just dying, burning to ask? Yes.
Sorry, I was wondering if you can kind of give us I guess checklist, like when we look at the, in lab when we look at the data,
Mhm.
is there a way you can kind of tell, okay, so certain qualities distinguish like a place cell, grid cell, and beta cell from each other?
Well, so I do have these examples, right, of in the lab 2 slides of these are sort of canonic examples of each. And so the best I could say in terms of answering that question is